In this video, we're going to learn how to solve trigonometric equations with square terms and constants. So, example 1, solve tan squared x equals 3 for x lying between 0 and 360 degrees. So, a slightly different example this time. We've not really dealt with any yet which have square terms. So it's worth pointing out at this stage that we should know from last year when we're squaring a trigonometric function what the notation looks like. So the squared comes between the sine, cos or tan and then the variable. So we would say that tan squared x, or we can say tan x all squared. Those mean the same thing, so we just need to be aware of that and how we write it down. Now, if we know that something squared is equal to 3, then we need to square root both sides in order to get that something. In this case it's tan x, to get that the subject of the formula. So when I square root both sides here, I get tan x equal to root 3. And remember, the root 3 is positive and negative. So obviously if you square a positive number, you get a positive. And if you square a negative number, you also get a positive. So that then results in when you take the square root of a positive number, your answer is positive or negative. So we need to take both of those into account here. So we've got this instance here where tan x is equal to positive root 3, but we've also got this instance where tan x is equal to negative root 3. So we need to take into account both of those, and we'll do that separately, which is why it's split up here as well. So when tan x is equal to a positive number, we know that our answers are occurring in the first and the third quadrants. And when it's a negative, when it's equal to a negative, we know our answers are occurring in the second and the fourth quadrants. So by now we should be really familiar with using that cast diagram and making sure you know which quadrants answers will occur in. Now if we take inverse tan of positive 3, that is one of our exact values, and that is 60 degrees. We should know those by now. And that calculation will help us with both of our cast diagrams, no matter whether it was positive or negative in the first place. So for tan x equals positive root 3, the answer in our first quadrant is 60 degrees, and in our third quadrant is 240 degrees. For tan x equals negative root 3, the answer in the second quadrant is 120 degrees, and in the fourth quadrant is 300 degrees. So you can see here we have 4 answers for x, and we're going to rewrite these in order though, because they're all answers in their own right. Even though we worked out the 60 and the 240 first, and the 120 and the 300 second, we're going to write them in numerical order. So x is equal to 60, 120, 240 and 300. Now, we don't normally see what the graph of tan squared x looks like, but I thought I would show you it to prove that we should have 4 answers. So this is the graph of tan squared x, and that lies between 0 and 360. And you can see here I've put in the line y equals 3. And you can see that there's 4 answers there. I've highlighted those. And again you can see that would be 60 around here, 120, 240 and 300. So those are our final answers. So I would pause the video at the moment and copy all of this working down so that you've got it for future reference. Okay, welcome back folks. We'll take a look at another example. The last one was in degrees, so we'll do one in radians this time. So we want to solve 4 cos squared x equal to 3 for x lying between 0 and 2 pi. So our solution then, we know that 4 cos squared x is equal to 3, that's what we were told. We want to aim to get cos x, the subject of the formula here. So firstly I'm going to have to divide throughout by 4. So that means that cos squared x is equal to 3/4. And in order to get cos x, the subject of the formula, I need to square root both sides of my equation. So cos x is equal to positive or negative root 3/4. Now, the square root of 3/4 simplifies because we can see the square root of that denominator. We're able to take that and get a whole number from it. So I can simplify that to positive and negative root 3 over 2. Now again, straight away, I'm thinking, well, that's an exact value. So that's going to come in handy here. So you should always be on the lookout for your exact values, and there should be alarm bells ringing in your head every time you see an exact value, so that you know to use that and you're not wasting time with the calculator then. So like in the last example, I'm going to take each of these separately. So firstly, cos x equals positive root 3 over 2, and secondly, cos x equals negative root 3 over 2. Now, inverse cos of root 3 over 2 is pi over 6. So I have already written my cast diagram in increments of 6 pi over 6 basically. So I've got 0 and pi is 6 pi over 6, and then 2 pi is 12 pi over 6. And the same here. Now it just makes it easier for dealing with the fractions in the next part. So cos x was equal to a positive here, so that means the answers are occurring in the first and the fourth quadrants. So the answer for the first quadrant is pi over 6, and for the fourth quadrant, 11 pi over 6. Looking at the negative here, my answers are occurring in the second and third quadrants. So that's 5 pi over 6 and 7 pi over 6. Again, I need to write my answers out in numerical order. So my answers here are x equals pi over 6, 5 pi over 6, 7 pi over 6 and 11 pi over 6. Now, if I just go back to the very beginning, 4 cos squared x equals 3, and have a wee look at the graph here. I have 4 answers, as you can see, and you can see that pi over 6, yep, that should be a third of the way along between 0 and pi over 2, so that's about right. 5 pi over 6, that's 2/3 of the way along between here and here. 7 pi over 6, a third of the way along here, and then 11 pi over 6, 2/3 of the way along here. So you can see that those answers coincide with the graph, so those are my final answers. So I would pause the video here before the screen goes blank and make sure you've got a copy of this in your notes jotter.